Okay, let's do the do now problem. We see here a rational expression that we need to simplify. What we do is we take each expression at a time and see if we can factorize that. So x squared negative x negative 12. We need to find two numbers that multiply to give negative 12 and combine to give negative 1. So 4 times 3 is 12. If we have negative 4 and plus 3, then we will have x squared negative x negative 12. So we can rewrite this as x negative 4 times x plus 3. And then 2x negative 1, there is nothing we can do it further simplified. So we write it as it is. And then 2x squared plus 7x negative 4. So 4 we have to multiply with 2. So we have to come up with two factors for negative 8. That would combine to give us plus 7. So 8 and negative 1. And this one, so 2x squared plus 7x negative 4. We cannot directly factorize. We have to rewrite the middle term as negative x plus 8x negative 4. Then we factor by grouping. So x is common in the first two terms and 4 is common in the second two terms. So we end up with x plus 4 and 2x negative 1. So we just go ahead and put it here. X plus 4 times 2x negative 1. And then 2x squared plus 6x, we see 2x common. So if then we take that out, we will have x plus 3 outside. Now, x plus 3 cross out. We also have 2x negative 1 and 2x negative 1 cancelled. So we end up with x negative 4 times x plus 4 upon 2x. And then we can write it as x squared negative 16 because we can use the difference of squares identity. X plus y times x negative y equals x squared negative y squared. So the same way we have x squared negative 16 upon 2x. So this is our final simplified expression. Okay, so this is how this problem is done. This was just a quick refresher about how to solve the rational equations. Now if we look at the steps about how to do that, so first you read and annotate the problem, then identify whether the situation represents multiplication, that means finding the product, or division, that means finding the quotient. So in this particular case, if you look at this problem, we had the multiplication of the two rational expressions. If the problem involves division, rewrite the quotient as a product of the first expression and the reciprocal of the second. So you'll just simply flip your second expression, bringing your denominator as the numerator and changing your numerator to denominator. Then you factor each expression in the numerator and denominator completely, like we just did. So this is like multiplication or division, and then it is, if it is division, then you flip your second expression. Third is whether you have multiplication or division. In any case, you factor each expression. So this is very important. Simplify common factors that appear in both the numerator and denominator. Multiply remaining expressions in the numerator, multiply remaining expressions in the denominator. If asked to find domain restrictions, set denominator equal to 0 and then solve. So in this particular case, if we need to give the domain restrictions, we will make 2x negative 1 equals 0. Then we will solve it for x. So 2x equals 1 and x is equal to 1 upon 2. And if we look at the second expression, when we have 2x times x plus 3, that means x is equal to 0 and x is equal to negative 3. So in this particular case, x should not be 0, negative 3, and 1 upon 2. So these three are the domain restrictions because they will make our expression undefined. Once you have a denominator as 0, your expression becomes undefined. So these are the steps. If you look at carefully all of these, try to work on one step at a time. You can get to your final answer eventually. So now we'll go to our teacher model and we'll do some problems. So let's work on the first problem. It says simplify the expression, and you notice that there is a division sign, and in the next step we flipped the denominator and the numerator. So we have 2x squared negative 2x coming up, x squared negative 9 going down. Now we'll do the third step, that is factor each expression separately. So x squared plus 3x, we see that x is common in these, so we just take x out and we write this as x plus 3. Then x squared plus x negative 2, we need to find two factors for negative 2 that will combine to give plus 1. So if we have 2 and negative 1, that should fulfill the condition. So we can write it as x plus 2 and x negative 1. So now we have changed two expressions into factored form. X squared plus negative 9 is basically x squared negative y squared. This is a difference of squares identity. So you can write this as x plus y times x negative y. So similarly, this we can write as x plus 3 and x negative 3. So coming to the last expression, we have, okay, I'm sorry, this is in down here. So x plus 3 times x negative 3. On the numerator, we have 2x squared negative 2x. So we just take 2x common and we end up with x negative 1. So now we have changed all the factors, all the expressions into factored form. And then x plus 3, we see that we have x plus 3 here and we have x plus 3 here. So x plus 3 cancels. We have x negative 1 and x negative 1. So they also cancel. And then we have 2x times x, which is 2x squared. And we have x plus 2 times x negative 3. So x plus 2 times x negative 3. Then when we multiply these together, we will have 2x squared upon x squared plus 2x, negative 3x is negative x. 3 times negative 2 is negative 6. So this is our final simplified expression. So you see that we had the division sign. We changed that to the multiplication sign by flipping this second term. Then we factored each of these expressions separately. In this case, we had to do with all of these. In this one and this one, we only had to take the common factor outside. And in this case, being the quadratic polynomials, we had to change into factored form. Once we did that, we simplified the same term on the denominator and numerator. And whatever we had in the end, we just did the multiplication. So this is how you solve this problem. Now let's go ahead and do this problem. So what are the domain restrictions on this expression? X plus 1 upon 2x negative 6. Domain restriction means the value of x for which your denominator becomes 0. So you make your denominator equal 0. Then you solve it. So 2x equals 6. And then you divide by 3. So you have x is equal to 3. So you can say that x should not be equal to 3. That is the domain restriction. Okay. Now, when there is such a case, you can define the domain in 3 different ways. Here in the first case, it says x is anything less than 3 or x is greater than 3, but x is not 3. Here it is called the interval notation. Your domain can be from negative infinity to 3 and from 3 to plus infinity, but and all of these, but 3 is not part of your domain. Okay, 3 cannot be in the set of your input values. And then the third is called the set notation, where you say that all x when x is not equal to 3. So anything, any value, any real number except for 3. Okay, and you can see that when we have 3 here, 2 times 3 is 6, 6 negative 6 is 0. So you have a 0 in the denominator, so it becomes undefined, the output value. Okay, so let's do the third example, but now we will have different options to pick from. So again, our division problem, t minus 2 upon t plus 4 divided by t minus 6 upon t squared negative t negative 20. So first of all, what we do is we have to flip it. So we rewrite this as t negative 2 upon t plus 4 multiplied by t squared negative t negative 20 over t negative 6. Now we need to find two factors for negative 20 that would combine to give us negative 1. So if we have negative 5 and plus 4, 5 times 4 is 20, negative 5 plus 4 is negative 1. So all three expressions do not need to be further simplified. The only one we change that to t minus 5, t plus 4. Okay, and then we just simplify. So now t plus 4 and t plus 4 cancel out. So we have t minus 2, t minus 5 upon t minus 6. If you look here, I have t minus 2, t minus 5 upon t minus 6. That's the only option I have. And here, the domain restrictions you do not get from here, your final answer, but from here, your initial statement. So you have two things in the denominator, t plus 4 is equal to 0, then t is negative 4. And when you have t negative 6 equals 0, then t is equal to 6. So negative 4 and 6 cannot be the domain, part of the domain. So now when you look at these two, they are the same expression, but we need to differentiate them based on the domain restrictions. So if we say that t is not negative 4 and 6, then we say that this is our correct choice. If you pick this one, your simplified expression is the same, it's okay, but the domain restriction is not correct. So this is wrong. Now let's do this problem, which is example 4. Simplify and state any domain restrictions on the variable b. Now, let's again go ahead, and since we have the multiplication sign here, we will simply go ahead and try to factor each expression. B squared upon b plus 4, nothing changes. B squared plus 2b negative 8, we need to find two factors for negative 8, that would give us plus 2. So if we have 4 and negative 2, that is negative 8 and then plus 2. So this will change to b plus 4 times b negative 2, and then here you can take b as a common factor, so b comes out and b negative 4 is outside. So now you had to change these two expressions into factored form. Once you do that, now the next step is to simplify. B plus 4 cancel out, and then b squared and b also cross out. You will have b times b negative 2 upon b negative 4. And if you just go ahead and multiply this, then b squared negative 2b upon b negative 4. Now, once you had this form, you had all the factors before you simplified. You could define your domain restrictions. B plus 4 is equal to 0, then b is negative 4. B is equal to 0, and b negative 4 is equal to 0 means b is equal to 4. So these three values, 0, 4, and negative 4, are your domain restrictions. So now, out of these, we see that this and this, both options G and H have the same simplified expression, b squared negative 2b upon b negative 4, but we have different domain restrictions. In this case, we have all three of these, 4, 0, and negative 4. In this case, 0 is not there, so we cannot take this one. We say that H is the right answer. We have negative, we should not be negative 4, nor it should be 0 or positive 4. Because whenever you have any of these values for B, your denominator becomes 0 and you have an undefined output. So that is not correct. Now, let's do this next problem. Which expression is equivalent to one of the four options given below, given x is not equal to negative 8, negative 1, or positive 1. So the domain restrictions are already given, and all we need to do is simplify this expression. So we start off with the first one, x squared negative 9x plus 8. We need to find two factors for 8. That would give us negative 9. So how about negative 8 and negative 1? So your first expression changes to x negative 8 and x negative 1. Next, we do the same thing, but this time we have to have plus 8 and plus 9 when we combine them. So we will have 8 and 1. So this time we're going to have x plus 8 times x plus 1. And then here we have x plus 8. We cannot simplify it further. And if we have 8x negative 8, we can have 8 common. So then we will have x negative 1. So now we have changed all these four expressions into factored form. Next step is to simplify. X negative 1, x negative 1 cancel out. X plus 8 cancel out. So you end up with x negative 8 upon 8 times x positive 1. And when we look at among all these four options, we see that option C is the right answer. X negative 8 upon 8 times x positive 1 we have. So it's going to be B. X negative 8 upon 8 times x positive 1. So C, this is how you define your domain restrictions. You just take your denominator as equal to 0 and then find the values of x for that. And when you simplify, you just factor each of the expressions and then you simplify. It's fairly straightforward, I hope. Now we do the last problem. Now again we have a division sign. So what we need to do is rewrite this and just flip the second rational expression. So when I have this here, I will have 2x squared negative 7x negative 15 at the top. And I will have 4x squared plus 7x negative 2 here. Now, when we want to simplify it, in these two terms, I have 3 common. So 3 comes out. X plus 2 is what we have inside parentheses. In these two terms, we have 2 common. So we will have 2 times x negative 5. Now this one, 15 times 2 is 30. We need to find two factors for negative 30. That would give us negative 7. So if we multiply 10 and 3, we do get 30, but for the signs, we need to have negative 10 and positive 3. So we will rewrite this expression as 2x squared negative 10x plus 3x negative 15. Then we have 2x common in the first two terms. So we factor by grouping. And then we have plus 3 common in the next two terms. So we have 2x plus 3 times x negative 5. So this expression we write as 2x plus 3 and x negative 5. Now we do the same with the second one, 2x squared negative 7x negative 15. Again we have negative 30. 15 times 2 is 30, negative 30. And we need to have wait a minute, I think, sorry, this is the second one, 4x squared plus 7x negative 2. So we multiply negative 2 with 4. We have negative 8. So negative 8, we need to find two factors that would combine to give us negative 7. So negative 8 and plus 1. We rewrite this as 4x squared negative 8x plus x negative 15. So then we have 4x taken out, x negative 2. Four x squared plus 7x negative 2. So here is we have negative 2. So again we have 1 common and x negative 2. So 4x plus 1 and x negative 2. If you want to confirm, negative 2 times 1 is negative 2. 4x times x is 4x squared. Then 4x times negative 2 is negative 8x plus 1 times x is plus x. So negative 8x plus x. No, actually, I'm sorry. This has to be positive. So we will have plus 8 and negative 1. So this is going to be plus and this is going to be negative. So x plus 2 and negative x plus 2. So x plus 2 and 4x negative 1. So here we will write 4x negative 1 times x plus 2. Okay. You have to be very careful with the signs, because if you mess up with one of the signs, then the entire thing is just wrong. You just see now that we were almost going way off because of one mistake with the sign. So make sure you don't do that. So once we have this expression now, we notice that x plus 2 and x plus 2 cancel out, and x negative 5 cancel out. So we have 3 times 2x plus 3, or 2 times 4x negative 1. Okay, so this is the final expression. If we want, we can expand it. We can just multiply. 3 times 2 is 6x, plus 3 times 3 is 9, and 2 times 4 is 8x, negative 2 times 1 is 2. So you can also write it as this form. So this is the final answer. So you see that we always see if there's a multiplication or the division sign. If there's a division sign in the initial expression, we flip, the top term goes down, the bottom term goes up, like here, and we have a multiplication sign. Once we have that, we have these 4 expressions. We try to factor each of these separately. So we have been practicing factorization of polynomials. In some cases, it can be as simple as taking a common factor out, like in this case and this case. In the other cases, it could be quadratic polynomials that we factorize, like here. Once we have all of these expressions in factored form, we simplify them, and then we have the final answer. So with that, I will stop here. You guys can start working on your independent practice problems. Again, which of the following is equivalent to this expression? You just, in this particular case, if you notice, this is already in simple form, simplified form. You don't need to factorize it. In fact, you just need to multiply these. And then you see which option is correct among these. Then you have this second problem. You have an expression and you need to find the vertical asymptote of the graph. So vertical asymptote, as you remember, is basically if you have the look of your graph, uh, vertical asymptote is could be a line which is a vertical line, and it is such that your graph would tend to reach this point, but it would never touch it. So as you go on and on, it may try to get there. And let's say if this is equal to 5, so that means x is equal to 5 is your vertical asymptote. And you can see that it comes directly from the denominator. You make your denominator equal to 0 and you get the vertical asymptote. Similarly, if we have x plus 8 equals 0, then x is equal to negative 8. So you may have a vertical asymptote like this. So you can have a dashed line. You can call this is negative 8. And then again, you can have your function somehow coming to this, and then it's trying to touch this line, but it never does, because x is equal to negative 8 is not part of your domain. Okay, this is the domain restriction. So again, vertical asymptote, if you see here, it comes from the domain restrictions. You just make your denominator equal to 0, and then from there you find it out. The third problem is, what is the domain of the rational function? You need to find the domain. So you need to keep in mind what could be the possible domain restrictions. This problem is very interesting. You have a problem and it's solved over 4 steps. You need to look at these steps very closely and see if the student did this problem correctly or she made a mistake during the first, second, or third step. So you don't need to do anything. You just need to review. The last problem, you need to find the domain restrictions for this expression, and you have 4 choices. So with that, we'll stop. So best of luck with your independent practice.